In this illustration, we'll see a rotating rod with a spring and a sleeve. Here the figure shows a horizontal rod mounted on axis OO' and a sleeve A of mass M attached to point P by a spring of natural length L0 and force constant K. Here we are required to find the work required in rotating the rod and attaining an angular speed omega. Here we can see when the rod will rotate, then the speed when it is attained by the sleeve, it will experience a centrifugal force in outward direction in the reference of this rod. And here we can see the spring force will balance the centrifugal force acting on it. So in this situation, we can draw the free body diagram of this sleeve A, where we can see with respect to the axis the spring is elongated and the sleeve would be revolving in a circle of length L0 plus x, where L0 is the natural length of a spring and x is the elongation. So it is experiencing kx in inward direction and the centrifugal force m omega square L0 plus x in outward direction. So in this situation we can write 1 rod attains the angular speed omega in frame of rod, which is the rotating frame. We can write for equilibrium of a sleeve, we can use m omega square L0 plus x should be balanced by kx. So on simplifying, we are getting the value of x as m omega square L0 by k minus m omega square. That is the elongation in a spring we are getting. And the energy stored in a spring is obtained when the sleeve was rotating on rod or when the angular speed was increasing from 0 to omega. So we can directly write energy gained by the system when it reaches angular speed omega is this energy. We can write as half kx square is the spring energy plus the kinetic energy attained by the sleeve, which is half mv square, and the speed we can write L0 plus x multiplied by omega square. And this is the total work done on system we can write, because total amount of energy gained is due to the external work. So on substituting the value of x, this work done or energy can be written as half k x we can write from here, which is m omega square L0 by k minus m omega square whole square plus half m, this L0 plus m omega square L0 by k minus m omega square whole square multiplied by omega square. That is the final result of this problem.